Hey everyone, this is Muhammad Nadeem and welcome to my YouTube channel. Today in this video, we will cover the electric power and its types in more detail. So here we have these things we frequently use in our home. All these things require some electrical energy, and that electrical energy delivered to these things by these things. So here these are actually the source of electromotive force. This is the wind turbine, the dam, the battery and the solar panel. These are used to deliver energy to these devices, and that devices convert this energy, in this case the electrical energy, into other form of energy. So here we have two types of power. So in this scenario, power is actually the energy delivered to the circuit, to the circuit per time. Here the energy delivered to the circuit per time is called the power in this scenario. Similarly, in this scenario, power is actually the energy dissipation here, the energy dissipation by these devices per time is called the power. So here the amount of energy which is delivered by these source of electromotive force. Let's take the rough example. If we have 1 joule of energy, so here we have 1 joule of energy, and we use one device from them. Let's say we use this iron. So the iron, let's say we have the iron. So the iron convert this 1 joule of energy into this 1 joule of electrical energy into heat energy per 1 millisecond. Per 1 millisecond. In this case, the power of this iron will be, so here this is the power of iron. The power of the iron will be 1 kilowatt. So 1 kilowatt is the power of the iron. And similarly, if the same device is used, so here the same device, power of the iron, in this case this 1 joule of energy is converted by this iron in microsecond. Then what will be the power of this iron? In this case, the power of the iron will be 1 megawatt. This is actually the roughly examples, roughly data. So here what I'm going to say is that the amount of energy dissipated by this resistors, in this case by these devices, the amount of energy dissipation by this divided per time is actually the power of that device. So here in this case, the energy dissipation per time is called the power dissipation, and in this case the amount of energy delivered by this source of electromotive force to the circuit per time is called the power delivered. So in this case, I am going to take the rough example as we have 1 joule of energy, and one of the electromotive force, the source of electromotive force, let's say we have the battery. We have 1 joule of energy, and the battery delivered that 1 joule of energy to the circuit in 1 second. Then what will be the power of this battery? The power of the battery will be 1 watt. Watt is the unit of the power. And similarly, if this wind turbine convert this 1 joule of energy to the same circuit, so here the same 1 joule of energy, but this turbine is convert this 1 joule of energy in let's say in a millisecond, then the power of this turbine will be 1 kilowatt. 1 kilowatt. So the power in this case is different than in this case, because here the in this case the energy is delivered to the circuit, and here the energy is dissipation. Now from here we can write that power is actually the energy deliver or dissipation per time. Here instead of the energy we can write T. So work done per time is called the power. This is actually the equation 1. And now we know that the potential difference equation is potential difference is the work done per unit charge. So from here we can find the work done, which is equal to let's say this is the Q. So here we can write this capital Q into V, and this is the equation 2. Put this equation 2 in equation 1, and the equation 1 now become power is equal to, instead of this W we will write this Q V divided by T. So this is the equation 3. Here this Q is given by the formula of the electric current. So from the electric current, I is equal to the number of charges per time. So here from here Q is equal to I into T. Let's say this is the equation 4. And by putting equation 4 in equation 3, the equation 3 becomes, so here equation 3 implies that power is equal to, instead of this Q we will put I and T into sorry, here we have T into V divided by this T. So this T and T will be cancelled, it become I and V, and this is the other form of the power. So here this is the equation 5. So from the equation 5 we can define the power as the product of the current in the circuit, and the voltage in the circuit is actually the power in that circuit. So here we can write the value of the voltage from the Ohm law. So according to the Ohm law, V is equal to I²R. So from so this let's say put this in equation 5, and due to this the equation 5 will be equation 5 become P is equal to I, and instead of this we will write I into R. So here I into R, which is equal to I² into R. This is the other form of the power in the circuit. So the power dissipation, the power dissipation is actually the product of the current to the resistor, and the resistance of that device is equal to the product of the square of the current and the resistance of device is actually the power dissipation of that device. So this is the other form of the power. So let's say this is the equation 6. So here we can replace this I from the Ohm law. So according to the Ohm law, V is equal to I²R, and from here we can determine I is equal to V by R. So by putting I is equal to V by R here in equation 6, so the equation 6 now become equation 6 now become P is equal to instead of this I will write V by R, and there is the square into R. One R and R will cancel, and due to which V square, it become V square by R, and this is the other form of power. So these equations represent um, representation represent the relation of the power with other parameters. So here we have the first equation of the power is in this case is equation 5, and the second equation power of the power is equation 6, and the third one is the equation, let's say this is a 7. So here and equation 7, equation 5, equation 6 and equation 7 is actually represent the power in the circuit. So these equation is representation of the power in the circuit, representation of the power. So this is the mathematical intuition of the power, and these are the different formulas which relate different parameters with the power. So until here we know the concept of electric power, and there are two types of electric power is generally the energy per time. If that energy is delivered to the circuit, then in this case that power is called power deliver, and if that power is coming from the energy dissipation in the circuit, then that power will call the power dissipation. And similarly this is from the definition of the power we can conclude different relation, and that relations represent the different the relationship between the power and different parameters. So here in equation 5 the power is related with the current and voltage, and here the power is related to the resistance R and current, and similarly here the voltage and resistance. So we will use these formula according to our desire, and it depends upon the problem statement.